So good morning to everyone. It's now probably, yeah, okay. So good morning to everyone and welcome to this session related to the infrastructure. These are our speakers for today, and so you will have the opportunity to talk with us, and also if you have any question, we will have a session after all the presentation to give the audience the opportunity to ask the speakers related to their presentation. I'm Rachele Bernardello, so I'm a research fellow at the University of Padua in Italy. My research activities are related to BIM modeling, geometric, semantic, digital data, and more focus on infrastructure projects. Today, I will present as referent for the Italian room of infrastructure, the results of two working groups that we have held in the past. So they are related to the bridge activities and to the road activities. A quick agenda of my presentation. I will introduce the Italian working group that are and then I will talk about the goals of this working group, and then the workflow and the methodology that we have developed, and then the results of our activities. So the two working group were related to the activities of bridge infrastructure and road infrastructure. So as you can see, the first one, it was related to the bridge, and so for the more technical people in the room, so it was in 2019, so at the beginning of the development of the standard for infrastructure. The second one, the working group of the road, related to road, was held last year, and so I will present the main goals that we have at the beginning of the two working groups were actually working with a lot of people of the Italian market, so trying to involve in the OpenBIM standards and in the OpenBIM activities, so a lot of people that normally don't work with OpenBIM standards. So the first one the first goal was to analyze the IFC standard, basically, and so spread the knowledge related to the standard. The second one was to test the IFC in real project and in real activities. The third one was to define a coordination between different models. As you know, so infrastructure normally has different disciplines developed with different software and developed in different ways. One of the other goals that we have was to mapping properties related to common properties in the IFC standard, but also how to work with the personal properties, with specific properties that clients or engineer company needs to map in their model. And at the end, so define a way to disseminate our results also to the people that didn't participate to the working group, and basically so also give a translation from the English on the English words and to the English dictionary into the Italian one. So how we work in this working group. The first part is to try to involve in the working group different member type. So the aim is always to put bring to the discussion stakeholders, engineering and companies, universities, consultants, and also software vendors that support the activities. The first part of the working group was based to the IFC standard knowledge. So most of the participants normally don't have a specific knowledge on IFC. They work and they are specific in the disciplines of road and bridge, but they don't have a clear knowledge of the IFC. So the first part was in both groups was to define the knowledge and to explain how the IFC schema works. Most part of is related to the entities, both material, objects, and so on, but also the spatial structure part. Then we work in both groups, we work on the use case priority. So the first part was to ask to the participants why you want to do, what you want from the model, what are the aims, what are the use cases that you want to develop in the specific part. Another activities was the one to work with multiple software. The objective is always to have a real a real activity, so have a model that people can explore and where you can test the activities and to test the discussion of the working group in a specific model. So you can explore the results. So in the buildingSMART Italian page, and so you can download the two results of the working group. The work of the bridge models, so we have developed two different models. One is a masonry bridge, which is an existing bridge, and the second one is a girder bridge. And the use cases was different. The first model was done to map the existing condition, and the second one is a model developed for the design to construction phase. So as I told you, you can explore the two models. So actually we have defined all the activities, all the information that we have developed exactly in a web page, and all the models can be explored and interrogated. The second, as I mentioned, the second working group was related to the road part. As I said, we have developed the different discipline models, so the one related to the road part, and the other two was related to the drainage system and also to the bridge and to the tunnel part. So as I mentioned, again, both of the models can be, so the models can be explored in the web page. You had also the QR code if you want to scan it. And so you can test clearly what are the results of the working group. One important part of these activities was the mapping of the properties. So actually one of the discussion activities that we have done is once you have to map properties into the model, so how you do it? Use the language, Italian or English in our case, of course. Use the standard properties of ISC or having personal properties and the specific properties. Actually, what we have done was trying to define, so in a list of properties that the participant to the project shared with the group, so we have tried to map the properties from the request, so from the information required towards the standards that when it was possible, and if there is no possibilities to map exactly the properties, so how to define exactly how to map the personal properties without having that activities when every client define its own list of properties and then changing from a client to another, you have different requests. And at the end, in the road working group, we have also tried to define so a use case related to cost estimation and to verify the possibility to use the IFC standard in order to define a cost estimation use case. So actually, as I mentioned at the beginning, one of the activities is also to translate some of the entities that are mapped in the IFC schema, and also to allow by the visualization and by the reading on the results, analyze which entities to use, giving also a translation of the definition and of the entities, and relating all of this information also to the national and international standard in order that our, so the companies can read, can understand which entities to use in which type of project. So both of we have produced two guidelines, so they are a little bit consistent, a lot of pages that explain IFC, that explain how to use the schema, explain how the working group developed their activities. And so both of them are downloadable in the page of the buildingSMART Italian chapter. So next step of the infrastructure Italian road chapter is to give, to have a training in OpenBIM standards specific for infrastructure. And so this is one of the activities that we are holding in September. And the second one is to start a new project proposal with, related to the design to construction phase, and so working with the construction companies, but also start talking about the management part, and so related to the responsibilities of the client, the RUP in Italian, and so working with these two types of activities. So thank you for your attention. And then now I will give the word to Francois for his presentation. Thank you so much.
All right, it's a beautiful Saturday morning in Quebec City. The temperature outside is unusually cold for a month of March. And I'm working on this PowerPoint. And if you look at the screen, this is where I am. I've got one blank sheet. I'm just lost completely. I've just so much content that I just don't know what to do with it. I've grabbed all the content that we have at Bentley. So I have like 400 slides. So what am I going to present? And I'm presenting alongside some great presenters as well. So I want this presentation to be really good. So I'm getting quite nervous. I'm getting a bit anxious as well. So what am I going to do? Well, I've seen high school kids cheating with it. So I'm like, why don't I try that myself? So I go on ChatGPT. And I'm like, okay, let me ask this thing. So I put that question in there, and I say, answer as a VP of software of a software company working on infrastructure to give me an outline of this presentation on the future of digital twins. And I say, do it as bullet points. And guess what I get? I get that. So I almost fell off my couch. So I was so impressed by this. Even my dog, the big Lulu, was like, oh my God. You know, this is amazing, right? So ChatGPT, in this case, really helped me to get unstuck and move forward. And for the record, I didn't use it, as the proper outline of this presentation, but it really helped me as a human-machine sort of interaction to really understand what to do. Oh, so this is what it actually did. Okay. So the reason why I'm telling you this is that we're truly at an inflection point. I don't know if when you were thinking about AI about 6 months ago, you were thinking we were that far. So ChatGPT and these sort of technologies allow us to answer any questions on any topics in any languages. And this is a big inflection point, and there's a lot of other technology coming together for that. So, buongiorno and grazie. So I don't speak Italian, I'm sorry. My name is Francois Valois. I'm VP of Software Engineering here at Bentley Systems. And I'm responsible for developing our civil, water, and mobility simulation products and to solve our users' needs. And I'm here today to talk about the future of digital twin and how it is redefining infrastructure. So as you know, digital twin are representations of the real world into a computer, right, digital assets. And we have plenty of challenges, right? Aging infrastructure, labor shortage, and just to name a few, climate change and so on. So essentially, we need to do more with less, faster, better, more sustainable, greener. I mean, the number of challenges are just insane, right? But the good news is the digital world, the digital twins, and other technology really help to solve some of these things. You can see more big data, more AI, more drones, more analytics, predictive analytics, and so on, 3D project delivery, 4D construction, all coming together to help. So digital twins, frankly, provides value at all phases of the infrastructure. So in design, you can model better, you can analyze better, and do it faster while still producing your drawing, that you need to, that are usually the legal documents. In construction, it can help you to avoid issues in pre-construction, to detect clashes and this sort of things. It's also simpler to track with a model in the field what sort of issues you might have and be able to track it very easily like this. And in operation, digital twin can help with predictive maintenance, IoT connections, and so on and so on, right? So really, it brings a lot of benefits at all the phases. But the best value out of digital twin is the information mobility across all the phases. So if we get to a world where we can get data from design to construction to operations in one seamless way without losing the important information, then we get really a systemic gain. So the whole playing field becomes better. And that's the whole idea of a digital twin in that context. So get the data to traverse all the phases without losing anything. And that's this really, and that will ultimately help the taxpayer lower the cost of building infrastructure, and we need that. Okay, however, we understand that technology is not enough. So we have to consider other aspects. So people, process, and technology is what's needed to bring this to life. You know, you cannot just be a technology company and hope that it's going to work. It just doesn't, right? So you need to bring everything together. So on the process front, we've done quite a bit of progress. For example, we've done, as humans, right? Not necessarily as Bentley, but you know, for contract, for example, we have this idea of design builds and 3Ps, which really help push innovations in different types. You know, the machine guidance and that sort of things really was pushed through these innovations. To a point where right now in France, for example, 85% of the projects are design builds, and I'm pretty sure that you have a large percentage of this here. So we must continue to do that. Business model and contract innovations are really, really key. So that's the number one thing. The next thing is for owners to define their strategy, right? We can tell in the US and around the world, people developing their digital delivery strategy. From design to construction to operations, they're basically determining who, what, when, how. You know, when we had multiple examples of that year at the buildingSMART conference. So very useful. Unfortunately, there's still much work to do on the legal front. So for example, in the United States, model is a legal document only in 4 states. So that's only 4 out of 50, right? So that's a lot of work that still need to do. And I'm sure that's the same case everywhere. For example, I was asking my local colleagues in Italy, and 40% of the project around here are done through BIM projects. That's what he told me. But still, the document of record for engineer is the plans. So there's like you create the models and you put it in the plans and you give it to the construction and they're like, okay, thanks for the plans, but you lose all of this. So initiative like what my colleague was presenting earlier to go design to construction are really, really important in that context. Next thing about people. So what do? We need to have a community of people connected globally that essentially are diverse from all kinds of ethnicity, you know, and language and so on, so connected together. So that's really necessary here. So we got to do this. And as Dr. Sean Wilson, former CEO of Ashto, said, we must produce and foster that sort of cultures within our own organizations and around the globe as well. And we need to start early. We need to encourage STEM programs, science, technology, engineering, and mathematics. And at Bentley, we believe in this. So every colleague has an amount of money to give to the STEM programs in high school. And we team up and we actually go support and give hundreds of thousands of dollars to those schools around the world. And we also give away our software for any university and students around the world alongside with content. Then we have way for people to become accredited developers on our platform and also on our products like OpenRose, where we have a Premier Scholar program, which essentially allows to the cream of the cream. So for an OpenRose expert to become even better and be a bit of an alumni of that program and have a communications and a network of other people around the globe to help this person progress. So people are very, very connected in this. And then finally, digital integrators. So people that will come and bring all of this together to help owners and operators and engineers. And we just signed a new agreement with WSB in the United States, which is joining as a digital integrator on the construction side of things, working with us. Finally, on the technology, of course, this is where Bentley is contributing the most, right? So we built a very comprehensive portfolio of products over time. But you can look at it in sort of three different arenas. To the left side, you have our open applications. So that would be open roads, open rails, open bridge, open tunnel, and everything open. We like open. And then the idea there is that those tools will create very rich models, semantically rich model, that can then be shared across the organization. But then you need to manage all your information as well, and that's where we bring the Bentley Infrastructure Cloud, which allows work-in-progress information management, but also construction and operations as well, all integrated in a suite of products there. And then what makes the magic happen is really the Bentley iTwin platform, which is digital twin enabling everything that we do. So it does enable our open applications as well as our server and cloud applications in that context to make it possible to become digital twin enabled. So the iTwin platform is an open source platform. So that was a bold move that our former CTO did. So he took the whole code base and made it available on itwings.org. So you can go now and look at what we're doing live. So it has open APIs to access the data and can be extended by any software developer. And we have a thriving community of developers, and we encourage you to join if you want to develop. But also as an engineering contractor, for example, you could develop your own extension to do this. So that's becoming a very common case. The iTwin platform is very powerful. It allows to load design data, including IFC files, reality modeling data, subsurface data, and sensor data and enterprise data, centralize all of that, manage the changes, manage the delta, and then, of course, make it available into a metaverse visualization as well as IFC. So we can see more and more of this. Bentley believes in open. I say we name our product open, but we also mean it. So we are involved in the buildingSMART International since 2019 as an international member, but we were involved before in the implementation. We have certified IFC professional. We are an implementer forum for IFC 4.3 and others related to infrastructure, and we do a lot of thought leadership. Just give you a little anecdote. I was at the Florida user group, the Bentley Florida user group in December last year. Great to be in Florida in December if you're from Quebec City. But over there, I asked in the room, there was about 400 people, and I said, who knows IFC? And there was one person that raised their hand. And I said, then I explained what IFC was. So in the civil world, Bentley can be contributing a lot and help explaining what IFC is and how it can be useful to people in this world. So Bentley does also implement things. Obviously, in our application, we have direct export of IFC 2.3, 4.0, and 4.3 as well. And then also in the cloud with the Bentley Infrastructure Cloud and iTwin, it can import IFC as well as export IFC in that context in the same way. And the advantage of the clouds is it's going to do it in a more industrial way and do it faster in that context. So on the design world, let's look at our open applications a little bit. So we can tell as soon as this starts. There is Open Roads Designer creating these very rich models, semantically rich as well, geometrically rich, and all that data can be used. As well, we have Open Bridge, which is uniquely positioned to do the modeling and the analysis all together in one package, creating these great bridges there. The drainage capability as well is brought all in the same platform and allows all of this to live happily together to create the subsurface model. And last but not least, you can take all that data and analyze it alongside the geotechnical information, which is essentially what you need to build tunnels and these sort of very complex structures or bridges. So subsurface is a big deal at Bentley. We're number one in that field. Okay. The infrastructure cloud can also help in that context. So let's look at an example here with design review. So we've civil enabled a design review, so it allows to visualize cross-section, super elevation, bridge, clearance, and all of this is connected as well with our open application. So you can review this easily, so you can have a project manager review that information, and then close a loop with the designer in a very structured way. So considering the super elevation, we have a patent pending on this, so essentially we're the only one that in a cloud application can analyze this sort of deep and complex analysis for civil engineers. So New York State DOT has been using it on their East 138 project, and they have actually integrated a large number of reviewers, 180 of them, 15 agencies to work together, which optimize their design review workflows quite a bit. So let's look at the construction side of things, again with the infrastructure cloud. So let me just click here. So we have this product called Synchro, part of the infrastructure cloud product lines, and essentially allows to manage your entire project from request for information, from project management, from access to data, to managing the data, managing the model, logging issues, and finally doing 4D modeling with all that data. All right, very complete. And then you can take that data in the field and have the model directly at your fingertip on an iPad or iPhone, and then use it there. Log issues, again, answer an RFI, take pictures, and have unstructured data as well tied to that. Again, this was used by WSB in a project which they allowed the Minnesota DOT to save $12 million, as well as doing the 4D modeling allowed them to save $500,000 by identifying issues in the design early on before it was constructed. So very, very good benefits there, as I mentioned earlier. So on the operations side, we do stuff as well. We have a platform called AssetWise that allows to do many things. So let's look at an example. So in AssetWise here, we have scanned a bridge essentially through a drone, and we're able to use AI to identify the cracks on that bridge, and this works with all kinds of infrastructure. You can also virtually inspect those assets, so you don't have to risk the life of your people, especially on bridges. This is quite a complex and dangerous thing to do. And all of this can also be used to do a health monitoring system. So in this case, on this bridge, we've assembled a BIM model, a reality model, a GPR scan of the surface you can see there. And then also overlay on top of that, again, from the Bentley Infrastructure Cloud, the ability to have IoT devices connected to this. So this notion of having these live infrastructure all connected together, that's the real digital twin, the complete, and having all that data together. Collins Engineering has been using our tools to scan bridges, for example, with 13,000 images together to create that very rich, reality model. They save 20% in field inspection by not having to actually go in places physically, but they reduce as well, the cost of construction of the rehabilitation of that bridge by 10 to 15%. So very good outcome on that front. And as Yogi Berra said, this wise man, he said, it's tough to make predictions, especially about the future. I'm going to attempt to do that for you, if that's okay, because I think we have a viewpoint on this. So I'm going to use the same framework that was presented at this conference, this Horizon framework. Horizon 1 is everything I presented. It's available live, commercially, so you can use it right now, and it's open source. Horizon 2 is basically the things that we need to do more. What do we need to do more of? Number one, get model as legal document everywhere. Model has to be this contract that we can have, and why not be an IFC file, right? That can be signed digitally and so on. And that data has to be as well used to build more resilient and more sustainable infrastructure. So better design, but also for construction, picking better materials, avoiding a number of trucks traveling and lowering the carbon footprint of that. And we need to have affordable and continuous monitoring as well, and modular design. On the Horizon 3, we need to do more. So we can do like the long-term future. You can imagine that one day, I don't know when, but you'll be thinking about a design, and the machine will do that. Maybe you ask ChatGPT, give me a great road design in Italy, and you get it. Maybe not. Maybe one day we get to something like that. So automation, multi-parametric design, as well as enhanced human-machine systems. So ChatGPT is a good example. I'm the human, it's the machine, it's helping me, but you can imagine robots helping construction workers. You can imagine drones, doing automatic inspection without anybody. So that sort of future doesn't have to be, bad. I think it's very, very positive. And finally, systems of systems. So digital twin connected to other digital twin without human being connected in the loop. So I want to leave you with a quote here from our former CTO, now retired Keith Bentley, which is this extreme visionary. He said that digital twin, for projects and assets will be the lifeblood and the central nervous systems of everything. And he says, and he insists, and that's why he made his own software open source, that it has to be built around open source, because this is the key to unlock the value to a broader ecosystem, but also to make the owners safe with their data. Because that's the public data. It's not Bentley's data, it's not the engineer's data, it's really the public data. So thank you very much for your time today, and I appreciate your attention. And now to our next presenter, Daniela. Yeah, thank you.
Thank you.
So thank you very much, Francois, for your overview on digital twins and so infrastructure project. Now we have Daniela Prea that is going to talk about standard and OpenBIM in Italfer. Thank you.
Thank you. Good morning, all. And please let me, in a few seconds, to thank the organization for this invitation and the opportunity to talk about Ferrovie dello Stato Italiano in Italfer, such an international audience. Let me introduce myself. My name is Daniela Prea, and I'm the head of Technology, Innovation, Digital Department in Italfer. This is the agenda of topics. So we talk about Italfer, we talk about how the OpenBIM mindset is applied in Italfer, buildingSMART working group, and the importance of OpenBIM standard for infrastructure projects. For the development and continuous evolution of the basic principle imposed by our industrial plan, Ferrovie dello Stato Italiano Group created 4 hubs: infrastructure, passengers, logistic, and urban, and Italfer is part of the first one. Each hub is a technical group composed by a company of the group created to assure common approach to guarantee same standards, same methods, and same processes. Italfer, both 38 years, work in large infrastructure projects for the conventional railway sector, in metropolitan and road transportation projects, and in the design of bridge, ports, station, also in Italy and abroad. Italfer has been charging over the last 10 years, and nowadays deals with innovation, sustainability, and integrating the resilience infrastructure, and with a great attention to young talent development. These are our 3P, the 3P of Italfer industrial plan. People, we will expect production. We will expect a revenue increase of about 45% in the next 10 years, as you can see. People, we will expect a big organizational growth, attracting about 1,000 more employers, with means 33% growth. And digital projects planning, we expect a steady increase of digital projects up to 18% comparing to the actual 13% of today. This year we are very full for all the opportunities offered by PNRR, and to upgrade and extend the national high-speed and high-capacity rail network, in particular in the southern part of the country. And you can see the number of the design projects and the billion for the work construction for this year, in the next year. Digital engineering and information management has been progressively introduced in Italfer since 2013 with the adoption of BIM methodology. Over the years, this setup evolved until definition a full dedicated team, TIDS, Technology, Innovation in Digital Department. And these are the units of this department, who includes about 100 people. And in the right part of the slide, you can see the main responsibilities. I want to explain and highlight that our team is the BIM and Digital, the twin center of excellence for Ferrovie dello Stato Group. So we work for this, we work with Bentley, we work with Autodesk, and we work to all our stakeholders for aim this plan and for aim a common standard for the group. TIDS is also involved in national and international working groups discussing about digital BIM standards and guidelines. And you can see we contribute to the IFC Rail Working Group with our client RFI and to the development of different guidelines. The following slide shows how we pay a lot of attention also to the innovation and not only to the standard BIM standards. On the left-hand side, we can see the project financed by governmental organization. And the other side of the slide, we improved aerial surveys to monitoring oil contamination and the Open Italy project. The power of BIM methodology is to store and manage the information related to such a complex and heterogeneous asset as the railway infrastructure, allows to pursue a life cycle approach of the whole infrastructure. In Italfer, we embrace and apply an information management philosophy throughout the infrastructure life cycle, managing design data, field data, as-built data, and maintenance data. This framework was key to start a standardization process using the experience in the last years, and the standardization started in 2016, and its purpose was to standardize all the processes related to the infrastructure life, from the BIM design to the training activities. Among the different involved in this process, related to approval approach, stakeholder management, OpenBIM for data exchange and interoperability, and the IFC standards. In Italfer, we deal with document, procedures, guidelines that explain the rules of the process we manage. All these documents are shared at the corporate level thanks to the CDA. The last standardization activities carried out, which is the implementation of procedures related to the standardization names, data, and information of the components of the infrastructure. These red points that you can see in the video are different parameters linked each other by geometrical rule to reproduce all the different types of the infrastructure. The goal is to target the complete identification of the component of the BIM models of the infrastructure that we develop with the parametric components and parametric templates. Just think about the data asset management process. The purpose of a project is to use standardized data in the library to be connected to digital asset catalog, such as materials management process. Similarly, the creation of a digitalized process that allows to coding of asset of the automatically involved into the client management platform for the maintenance and operation phase. Another application is about life cycle works, a life cycle process. To score the sustainability goals, Italfer is currently developing a tool to allow life cycle analysis, and the process involved a preliminary analysis of the state of the art of the complex information set, so then materials, work process, transformation, maintenance, end-of-life, civil works, related to the traditional design process in Italfer. The aim is to set up an algorithm and customize the LCA analysis capable of reading data from the model and connect them to the LCA database. Regarding the standards applied to contractual documents, I want to show how the approach changes depending on the procurement model in which Italfer is involved. We are involved in captive projects, so Italian one, and no captive for us are also national, international ones. In second case, Italfer can play the role of a general consultant of a client supporting the tender phase documentation, drafting, and can play the role of the work supervisor. Italfer applies all the standards according to the different regulation in updating and drafting the EIR, the productor BEP, and the post-contractor. During the design review of the projects developed by the contractor, Italfer is called to manage a lot and a huge amount of data coming from several BIM models. As you can see, the numbers on a slide. It's clear that how OpenBIM is the key strategy to support all this work, all this review process that for us is very important. Our standards include use of two different platforms. One is the collaborative process, and we use that CDA for the design phase. And the other is digital twin application, like used for the communication to the stakeholder, or also for monitoring and so on. The digital twin is the Italfer standard to communicate the design to the government's authorities, and is the instrument used for the approval process. By the use of different views, we can go through the model disciplines and layers. And also info points are placed to show technical drawing and information, all of the reports, to all the different clients, all the different users. The use of a twin platform and IFC files support the collaboration among the different actors of the process during all the stages of the project. The model is built with the native files of all disciplines stored in our CDA, and the IFC is then exported directly from digital twin platform. Last year, Italfer contributed as technical support to RFI, engaging several young engineers to finalize and allow the publishing of the format IFC, and we are working for the next phase. The ongoing applying IFC working group is focused on two business cases, the IFC model federation and the stationing and of alignment. Italfer contributes to definition of the data set and is currently involved as an active support to the software vendors during the test phase. Finally, following 4 slides about our application in international projects that Italfer was involved in a heterogeneous team, and we have to speak with a lot of different people, a lot of different approach. OpenBIM standardization and interoperability represent the common language for purpose of this goal. For the Turin Lion, for example, railway infrastructure project, Italfer was connected with TELT and AGAT to produce a set of standards in terms of CDA, naming convention, libraries, to aim the design review and work supervision goals. Italfer was also involved in the tender phase or ISP2 phase on railway project. In this activity, we worked in JV with the Aegis and carried out a standardization process covering all aspects of the design to aim for an homogeneous output. As the scope concerned, the design for D and 5D in the next years, we expected the process to reduce risks during the construction phase in a completely traced and digital way. Bergamo is an example of mass transit design. We work with a lot of Italian company. This tramline is a complex asset consisting of bridge, technological building, tunnel, stops, and utilities. And at the end, Italfer recently is in DJV with Arcadis and GACD for a project of about 130 kilometers line in Brisbane area. Italfer plays an important role covering two prestigious positions in the digital engineering project organization. The digital engineering data lead Australia and Italy with 4 people of our team in Brisbane. And as highlights in the left-hand side box, this responsibility covers the guidelines of the digital engineering policy of the whole project and the digitalization process applied to the delivery returnable. And I want to leave you with a quick final thought. Collaboration seeks for a common language. Thank you.
So thank you very much, Daniela, for your presentation. Now we'll leave the stage to Mark Altman and this presentation about GIS and how it enhances the value of BIM. Thank you very much.
Thank you. Thank you for the opportunity here. I'm going to start just with a very quick, unscientific show of hands. I expect everyone will probably raise their hand on this quick question. Who would consider themselves very familiar, advanced, or an expert in areas of building information modeling, BIM? Half the room? Okay, I would have expected higher. How about GIS, Geographic Information Systems? 1, 2, 3, kind of 4. Okay, that's what I expected. And that's really my background as well. I started out many years ago in the AEC world. Hopefully this works. There we go, that's me. This is not a picture of me, but I always like to give credit to who many people believe to be one of the founders, the grandfather, the godfather of computer-aided design. That's Ivan Sutherland, who's well known for many topics in the world of computer technology. In front of his computer in 1962, a program called Sketchpad. You can see him with his stylus touching the screen itself, actually designing a chair. I got involved in CAD a little bit later than 1962, actually in the late 80s, early 90s. This is a version of AutoCAD when I worked at Autodesk back in the late 90s, early 2000s. I did several things, went back to Autodesk in the mid-2000s and worked on Revit, some of the very earliest versions as Autodesk acquired it from Charles River Software. And for the last 3.5, almost 4 years, I've been working at Esri, acting as a bridge between the worlds of AEC, CAD, and BIM, and the world of GIS, which, from the show of hands here and typical, is not as well known amongst architects, engineers, construction professionals, asset operators. Most people, when they think about GIS, they think of two-dimensional mapping, flat maps that maybe still just get printed out on paper or show up on screen, or maybe they even jump over and think about Google Maps as GIS. At Esri, GIS is much more than just maps. It's field operations software, data collection out in the field, analyzing that information from a spatial context and applying data science to the massive amounts of information which can be visualized and understood in 2D and certainly 3D maps. It's layers and layers of information that get collected from satellites, fixed wing, drones, terrestrial-based scanners and imagery, and remote sensing devices. It's certainly visualizing the information that is coming from IoT sensors in real time and analyzing that information in context to the maps, to the buildings that we drop into our 3D maps. Visualizing that information, understanding it in a way that CAD and BIM tools typically do not and cannot, and were not built to do. Data management of massive amounts of information presented in ways that anyone can understand. We all can look at a 2D or 3D map and glean insights from it. And then our entire platform is available for developers to extend through APIs on the desktop, through the cloud, through enterprise engagement. So modern GIS is much more than maps. It's turning those base maps, the basic information that we think about GIS, into apps, into applications. Esri's work in the world of bringing BIM into ArcGIS, our flagship product and platform, goes back many years, almost a decade now, with our initial import, ETL, export, translate, locate, BIM data into our geodatabase. We produced a desktop application in 2015, which I'll talk about in a minute or so, called ArcGIS Pro, which I would say anyone who's doing any work in BIM these days should have a copy of ArcGIS Pro right next to it to extend the value of that BIM information. We've added various functionalities, capabilities along the way, brought BIM directly into the geodatabase. You can see a line there drawn in 2017 when Autodesk and Esri decided it didn't make sense for us to be competing anymore for the mind share of AEC professionals and operators of facilities, but instead to work together. And from that point forward, we started directly importing Revit files, DWG files into our flagship applications and allowing our base maps and maps that get generated in our applications to be visualized and understood within their design tools as well. We started implementing IFC back in 2020 or so, and we are up on the leading edge, if you will, with our 4.3 implementation of IFC, and I'll have a few examples here. What's not shown is that I joined Esri around very end of 2019, December 1st actually. And December 15th, I called Ian Howell and said, Esri needs to be a very active member of the buildingSMART International community. It was something that I've been involved with since the very earliest days of buildingSMART, when it was known as the International Alliance for Interoperability. I'm a big proponent of the message, the capabilities of interoperability, and I'm proud to say that Esri is taking a very active role. With respect to our connections and integrations specifically with Autodesk, I'm not going to drill into all of the boxes shown on screen here, but what you'll see is a number of bi-directional communications between Autodesk's flagship products and Esri's as well, both desktop and cloud. So whether it's Civil 3D, bringing in maps to help you understand where your bridges and roads and tunnels and alignments exist in real-world space, or visualizing information, our maps within InfraWorks, taking Revit content directly into our ArcGIS Pro desktop application to visualize and understand and analyze the geometry and properties of BIM content, or most recently, a product called ArcGIS GeoBIM that we worked together with Autodesk to bring their cloud solution, Autodesk Construction Cloud, with our cloud solution, ArcGIS Online, so that a connected data environment can exist between these two great platforms. ArcGIS Pro, I've mentioned it a couple times. It is, like I said, it's our flagship application. Anyone who's doing any kind of work with BIM content, whether it's buildings vertically or roadways and railways horizontally, just a very powerful application for bringing together data from many sources, visualizing, analyzing, extending it, and then potentially sharing it with the world through web scenes. ArcGIS GeoBIM, a fairly recent application, as I mentioned, brings together the CAD and BIM content that you would create and store in Autodesk Construction Cloud, visualize it then in a single map environment, click on objects, get down to that data, those files, that information that exists in Autodesk's environment, and again, this connected data environment. So why am I here talking about CAD and BIM and GIS coming together? Why is Esri making this significant investment in time and energy and people and partnerships around the AEC world? Well, AEC projects, whether they're roads or rails or buildings, highways, hospitals, airports, they all are spatial. AEC projects get planned, designed, built, and eventually operated somewhere. And that's what GIS is about. GIS is about location. Location matters in the AEC world. And yet, as Francois alluded to, a blank screen, which is typically the starting point in CAD and BIM applications, is a somewhat scary situation. When you have to design a project with some context, but your screen starts out blank, that's a big challenge, but GIS helps you overcome that challenge. And in AEC work, I would say more so than any other industry, any other group of professionals, the broad range of data, the file types, the information sources that need to be brought together, whether it's satellite imagery or terrestrial imagery or CAD data, information that you have to glean out of spreadsheets, that all can be brought together in GIS. And location acts as a common denominator, a connector of all of the type of data that AEC professionals work with. GIS is brilliant in that manner and quite unique. And I've found over the few years that I've been at Esri and been involved with customers who are bringing the strength of BIM and its granular data and the breadth of GIS, that when you're able to connect data in your applications, you end up connecting people. You end up finding that people work better together. Rather than throwing information over the transom and over the wall and over the fence to each other, but actually integrating around location data, you're enabling digital transformation, which is now just simply part of our industry. And I don't mean digital transformation in the form of going from paper to PDFs, but really changing workflows around data, around information. And digital transformation is critical because there is now an expectation by owners that projects are delivered digitally as well as physically. At the point when the keys are handed over to the owner, when the ribbon is cut for that new roadway, when the airport terminal is opened, there is simply an expectation that that physical deliverable has been managed digitally along the way, and that a complete digital handover is part of the process. And again, location acts as that integrator of data, enabling digital transformation, enabling digital delivery. And I've been in this industry, as I showed with it for my first slide there, for quite some time. I've never seen such rapid interest, adoption, acceptance, and expectation of technology. I think gone are the days where we tech shame our industry, where we talk about the lack of adoption and the lack of progress and the lack of productivity and the lack of technology usage. I think those days are gone. We are now adopting technology, expecting technology, and again, GIS acts as a connector. So I want to talk a little break here just for a minute or two and dive in a little bit into the IFC support using the words of one of our product managers, product owners, a gentleman named Don Cuny, who's been involved with Esri and its AEC technology support for some time, a little video that I asked him to put together. So hopefully the audio can run on this one.
Using its desktop software, ArcGIS Pro. This design data is read in its native file formats directly without the need for conversion. Supported BIM formats include IFC files, Autodesk Revit files, and 3D CAD files from Bentley MicroStation. Combining this BIM information with other sources of design data and other GIS data formats provides a capable environment to analyze and visualize project data. Design information can be viewed in the context of new and existing construction, as well as how it interacts with the natural environment. ArcGIS Pro is used to conceptualize designs, mitigate problems, and share design alternatives within their real-world context. The complex geometry and rich attribution of IFC files is supported, including the IFC 4x3 format infrastructure files for roads, rails, and bridges. Support for IFC 4x3 files was added in Esri's ArcGIS Pro Release 3.0. This GIS, BIM, CAD, and IFC data can be viewed over the web by broader audiences through the publishing of comprehensive 3D web scenes. Web scene content can be published using ArcGIS Pro and then utilized through a simple web browser. Support for IFC files within Esri GIS applications allows for the access and sharing of information from many different software sources. Direct access to information within IFC files is an important part of a practical data interoperability strategy. This information is used to conceptualize design intent and populate the system of record for operations and maintenance. Esri supports IFC files through the adoption of software libraries created and updated by buildingSMART technology partner, the Open Design Alliance, of which Esri is a founding member.
Very good. So I've mentioned a couple of times Autodesk as one of our partners, a strong partner in AEC, and I'm going to show a couple of examples, including Autodesk and others. So this was a bridge model that we received, using it internally for testing. So you'll see GIS plus OpenBIM in a few contexts. This first one, like I said, is from Autodesk. This was me reaching out to one of our developers, asking for a model about a week ago that they used internally for testing that I could demonstrate here that was based on IFC 4.3. So he simply brought the model into ArcGIS Pro, turned on a base map as an underlay. I then opened up the web scene, which he created for me, turned on our slicing tool, navigated around the environment, and what you're seeing here is the model breakdown structure within a GIS web scene produced originally from ArcGIS Pro. Another example, just a couple of days ago, reached out to Francois and said, hey, we're going to be together in Rome. Let's see if we can get our hands on an IFC model produced from Open Roads. So in this case, a model was sent to me, I think just on Monday. I shared it with our developer, brought it into a web scene here. We're turning down the transparency of the background because this is actually a tunnel. We wanted to visualize it not being obscured by the ground. And again, just a simple web scene generated from ArcGIS Pro, saved out to a public website that I then can just navigate very easily, understand the geometry, select an individual object, and all the BIM properties that were generated, edited, created in Open Roads in this case are available here just for me to visualize. But all of these attributes are available within the GIS environment for much more in-depth analysis than just popping up on a screen. Similarly, I reached out to Rodrigo on Monday and said, hey, you've got some great models. Would love to visualize those in our GIS environment. So a model was shared. I sent it over to our developer. Here you can see a recent capability of our web scenes. We can actually visualize weather conditions. So it seems to be snowing on your bridge. Sorry about that. And again, just a few predefined views were set up by the developer, allowing me to jump around very quickly in this web environment of BIM information generated in a completely outside application that no one, quite frankly, probably at Esri other than myself, have familiarity with to any degree, brought in the 4.0 file, I believe in this case. I think this is an IFC 4.0 file you told me. You can see the properties of the beam that I selected, changing our view to another place, zooming in underneath the bridge in just a second here. Similarly, about a week ago, I reached out to our friends at Akka Software and said, you guys are showing some great stuff. Could you share that model with me? Well, their feedback was, well, the model that you saw that we posted on LinkedIn and the model that you saw on our website isn't one that actually is ours. You need to reach out to iStram. So I contacted iStram, asked for the model, and here you can see similar kind of situation. Asked for a 4.3 file, shared it with our developer, geolocate it in the right location. A few views were predefined for me to very quickly just generate a video with, again, all the geometry at the fidelity that you would expect from the BIM authoring tool into the GIS environment, all the properties of all the objects available for any kind of analysis that GIS is capable of, whether it's just a visual analysis or in-depth spatial analyses. And then another example, they actually shared two models with us. This is an interesting one because just last week I was with a company who I'm going to mention in a second who described how complex a project they were working on. Not this exact one, but it was a freeway overpassing a traffic circle, and the 2D plans just didn't convey to the many stakeholders the complexity of this interchange. So they needed 3D, and they actually used Esri solutions to develop it. In this case, again, it was a model we received from iStram just a couple of days ago, brought into ArcGIS Pro, saved out to a web scene for me to navigate very easily. So those were all examples that I point out of receiving 4.3 files within a last-minute request, bringing them into ArcGIS Pro and enabling visualization, analysis in a GIS environment, a contextual environment. Could have brought in hundreds, thousands of other layers if I wished to perform GIS capabilities. These next set of examples actually are real-world customer examples. HNTB is a 113-year-old engineering construction consulting firm based out of the US who focus on bridges. The bridge that you see in this image here is about an 80-year-old lift bridge in Norwalk, Connecticut that they are responsible for building a new bridge right next to it. So they modeled the old bridge in a combination of Autodesk and Bentley tools, output it using a variety of tools into a GIS environment. The little blue columns that you see there, you see the one on the lower left corner, actually is the indicator of an IoT sensor providing feedback into this dashboard within ArcGIS GeoBIM, which I mentioned earlier, allowing for a digital twin to be understood and investigated. So those IoT sensors are reporting back into the dashboard, into this application, seismic activity, temperature activity, humidity, because they're building a new bridge next to this old bridge, and they want to make sure that the pile driving that takes place is not going to potentially disturb this old bridge as it's lifting. So you can see what looks like a very CAD or BIM-like environment, but in real-world context, with IoT sensors delivering digital twin capabilities. Another example, construction company based out of Canada, Pomerleau Construction, bringing together IFC data into a BIM environment. I think this was 2.3 data though. So they've got IFC geometry and all of its properties. They've placed sensors in the concrete that are allowing them to know when the concrete cures to the right degree, strength and temperature, so that they can execute on the construction project most effectively. So CAD, BIM, GIS, IoT sensors brought together, and again, a digital twin kind of deliverable for construction management, so they're not wasting time or perhaps putting up the steel before the concrete has cured completely, but optimizing their construction, bringing GIS and other technologies together. Skanska, this is their UK infrastructure division, bringing together OpenBIM, IFC 2.3, and Esri's tools for construction and design management. They are one of the contractors, as are many on, in this case, I think this is the Crossrail project. They also are deeply involved in the HS2 project. And you'll see as this diagram builds out, they are reliant on most of the primary design, engineering, CAD and BIM tools that you'd expect, a combination of Autodesk and Bentley solutions. They're using the IFC 2.3 format as their, let's call it the lingua franca, their Rosetta Stone, their means of communicating. They're QAing the IFC data to ensure that their design and engineering information is correct, and then feeding that out to various workflows. It's their collaboration and sharing environment for project interoperability. So on this particular short example here, you'll see these red cones pop up all over the screen. The team are going out with Esri's field-based tools called Survey 123 in this case for collecting real-world field conditions that are very precisely geolocated, dropping those locators on a map and then reviewing the conditions of the construction site during design and engineering with the team in this dashboard-like view. The model geometry that you're looking at came from IFC. The properties on the lower right corner are a survey that was collected in the real world, and the little cones indicate issues that need to be examined and understood before design can be nailed down. Another example from Skanska, bringing together, this was the Crossrail project to the east and kind of south of London, connecting east to west. A combination of reality capture information, satellite imagery, OpenStreetMaps model data, BIM information from various tools brought together through IFC, and then going out again with field-based survey tools to understand the status of the piles that are being drilled and driven and QA'd, so that they know in real time back in the office what is happening out in the field. You can see a timeline progress in the lower right there, more and more piles showing up on screen. So a combination, again, of CAD and BIM and GIS and survey data to help understand status of project in real time. And then finally, we saw on the first day here, the opening day in the plenary, Akka Software, developing a solution with Esri's GIS capabilities at its core, OpenBIM IFC as the language, the data, truly a partner building on Esri's capabilities in ways that we ourselves, quite frankly, have not done. Myself and my colleagues got to see a demonstration of some of this a week or two ago, and we had to mute our phones and had a side chat going. We were literally clapping as we saw these capabilities. bringing together dozens, hundreds of IFC models into a single environment, and in real time exploring the attributes, understanding the depth of the BIM information, jumping across the country to another project with just as much detail, just as much information, being able to actually do BIM modeling, BIM authoring in a GIS environment through a cloud interface. I mean, where does the BIM start and where does the GIS end? Or where does the GIS start and where does the BIM end in these scenarios? They're coming together in ways that I don't think most of us or any of us 5 years ago would have thought possible. But this is where we're at. We're at a place where GIS is just as important a solution, a tool, a capability in the hands of AEC professionals as BIM has been for the last decade or two. So 1 or 2 last plugs here. We have a conference taking place in just 2 to 3 weeks now in Frankfurt, where projects like these will be highlighted. I think we've got a total of about 60 customers presenting their projects. A couple of them I mentioned here. I think we have just as many technical sessions being led by our solution engineers, showing BIM and GIS brought together, extending the capabilities of BIM through GIS solutions. And then finally, if you'd like to contact me, here's 3 ways: esri.com/AEC, an email address that drops into a number of our inboxes or my email directly, or snap the QR code. It'll take you to a quick survey, a couple of questions, and again, give us an opportunity to connect with you directly. Thank you.
Thank you very much, Mark, for the presentation. Now the last speaker, Rodrigo Bortolini from CSP, and he's going to talk about the role of IFC for structural health monitoring and bridge management system. Thank you very much.
Buongiorno a tutti. Si sente? Correttamente, sì.
So
Okay.
for the English speaker, so we have in case. So are you going to do the presentation in Italian? Or
In Italian.
Italian,
Yes,
so if you
Italian.
need the translation, you have the support
Okay.
of the headphones.
Buongiorno a tutti. Dunque, la mia presentazione di oggi tratterà il ruolo del formato IFC per il monitoraggio strutturale e le piattaforme di gestione basato su quindi modelli informativi BIM. Io sono l'ingegner Rodrigo Bortolini di CSP FEA, sono il product manager di un software InfraBIM Midas CIM. CSP FEA è una compagnia responsabile della distribuzione e di supporto di tutti i software relativi alla software house Midas IT in Italia. Siamo un'azienda che ci riteniamo molto innovativi perché ci piace conoscere, comprendere tutto quello che riguarda l'ambito AIC e trasmetterlo ai nostri clienti. Prima di incominciare a andare a trattare un po' più il succo della mia presentazione, vorrei dare alcuni spunti per quanto riguarda il titolo dello stesso. Infatti ci sono delle parole che magari non sono conosciute o altro, quindi cercherò di descrivere brevemente il titolo. Parleremo di Bridge Management System, sono delle piattaforme di gestione che hanno il ruolo di integrare al loro interno tutte le informazioni necessarie a comprendere le infrastrutture come ponti e viadotti. Successivamente parlerò di monitoraggio strutturale, che sono dei sistemi di tipo autonomo che vengono installati sulle nostre infrastrutture e ci permettono di capire giorno per giorno la condizione della mia opera. Modelli BIM, InfraBIM, quindi in questo caso andremo ad analizzare una modellazione con un software BIM authoring dedicato proprio a modellazione di ponti, viadotti e anche gallerie. Ed infine andremo a capire come questi dati possono essere trasmessi da questi modelli BIM alle piattaforme di gestione. La proposta del flusso informativo si compone. Innanzitutto dobbiamo andare a capire la nostra infrastruttura, quali sono i suoi dati più generali, quindi andiamo a prendere la nostra documentazione storico-amministrativa e andiamo a comprendere tutti i dettagli. Successivamente si va in situ, si fanno delle ispezioni, quindi si va a comprendere lo stato attuale della mia infrastruttura. Si creano questi modelli informativi BIM dove ci andiamo ad allocare al suo interno delle informazioni. Si ha quindi un export attraverso il formato aperto IFC e l'introduzione all'interno di queste piattaforme di gestione. I dati relativi ai veri dati dinamici relativi ai sensori vengono introdotti, secondo questa proposta, esternamente e non attraverso direttamente al software di modellazione. In questo caso tutte le informazioni che andrò a riportare riguardano alle linee guida per la classificazione e la gestione del rischio delle infrastrutture esistenti, è una linea guida italiana, e si suddivide in vari livelli. Man mano che aumentiamo con il livello avremo sempre più informazioni al loro interno. Infatti noi partiremo con dei primi dati che sono relativi al censimento della nostra struttura e alla geolocalizzazione nel territorio della nostra infrastruttura. Successivamente si hanno dei dati maggiori, quindi relativi alla mia struttura attualmente, che caratteristiche ha, quali sono i difetti che ha la mia struttura. Successivamente si va a capire qual è la classe di attenzione, significa la mia struttura attualmente è una struttura che ha un buono stato di salute o un cattivo stato di salute. In particolare andandoci a focalizzare su alta e medio-alta, infatti è quella che noi avremo maggiori informazioni, quindi relativi al monitoraggio strutturale, dati relativi ai modelli FEM, e ai modelli di tipo predittivo, quindi capire la mia struttura, lo stato di salute di struttura nel mio futuro. Quindi i miei dati più generali sono, quindi, come detto in precedenza, dati relativi quindi alla documentazione storico-tecnica amministrativa, geolocalizzazione del mio modello, quindi tutto relativo anche al rischio idraulico. Successivamente i dati relativi alle ispezioni in sito, quindi i dati relativi a fotografie, dati relativi alle prove distruttive e non, queste ci permettono di capire le caratteristiche vere e proprie dei miei elementi strutturali, successivamente anche quelli relativi alla manutenzione della mia struttura ed infine i dati del monitoraggio strutturale. Ora, che cos'è un monitoraggio strutturale? Il monitoraggio strutturale sono dei sistemi di tipo autonomo che vengono installati sulla mia struttura e permettono in continuo di ricavare delle informazioni. Queste informazioni sono importanti perché sono relative, possiamo svolgere delle ispezioni da remoto, quindi controllare direttamente dal computer o dal tablet come sta la mia struttura. Avere in possesso, impiegare degli alert, quindi avere delle informazioni istantanee su possibili problemi ed infine riuscire a utilizzare questi dati per riuscire a creare dei modelli predittivi, quindi capire la mia struttura come si comporterà. La struttura tipica di un sistema di monitoraggio è composta da una mia infrastruttura, una mia struttura da dover monitorare. Ci installiamo dei sensori. Questi sensori mi danno un output, quindi mi danno dei valori relativi al comportamento che io voglio andare a ricercare. Questi vengono assimilati attraverso delle centraline di acquisizione, vengono trasferiti attraverso delle reti a delle banche dati. Quindi questo è il mio flusso tipico dei sensori. Successivamente bisogna anche comprendere che tipologie, macro tipologie di sensori trovo io in commercio. Troverò due tipologie. Avremo dei sensori statici e dinamici. Per sensori tipo statico noi andiamo a ricavare dei fenomeni che avvengono molto lentamente nel tempo. Per esempio, se noi vogliamo andare a ricercare un allargamento di una fessura di un mio elemento strutturale, il dato che noi andiamo a ricercare è un dato non concentrato, quindi per esempio noi andremo a svolgere un campionamento per ora. Invece per quanto riguarda i sensori di tipo dinamico, noi andiamo a ricercare delle quantità di dati molto elevati. Per esempio, se io mi ritrovo in una mia infrastruttura, in un giunto di questa mia infrastruttura, voglio andare a ricavare l'accelerazione data da un carico mobile su questo mio giunto, dovrò avere un campionamento molto elevato in un intervallo di tempo molto ravvicinato, quindi 100-200 campionamenti al secondo. Un aspetto molto anche importante è quello legato agli effetti maschera. Gli effetti maschera i nostri dati non sono perfettamente orizzontali, quindi sono anche difficili da studiare e capire. I nostri ispettori fanno fatica a comprendere il reale comportamento della mia struttura. Quindi questi effetti maschera sporcano il mio dato. Quindi ci sarà anche un processo successivo nel capire come pulire questo mio dato, quali sono le tecnologie per farlo. E questi dipendono per esempio dai cicli stagionali o comunque anche il passaggio dei carichi mobili sulla mia struttura. Quindi qual è il mio percorso totale del mio scambio di dato in questa situazione? Quindi io scelgo la mia infrastruttura, quali tipi di sensori devo installare sulla mia infrastruttura? Mi servono statici, dinamici, solo dinamici, entrambi? Scelgo i miei sensori, da quel momento io capisco, ho questo output del mio dato. Questo mio output, come lo processo? Che tipologia di pulizia devo fare per il mio dato? E poi un aspetto molto importante che ho bisogno che tutti i miei dati vengano condivisi all'interno di queste piattaforme di gestione o quale tipologia di dati, per non avere un sovraccarico di informazioni all'interno di un unico solo storage di data. Quindi più o meno questo è tutto il processo da svolgere quando ci si chiede nel sistema di monitoraggio quali informazioni voglio ottenere. Successivamente si ha una modellazione, in questo caso InfraBIM, quindi qua è un ponte su Brenta in provincia di Padova, è un ponte a 2 impalcati, misto acciaio e calcestruzzo post compresso. Questo ponte ha avuto negli anni tantissimi interventi di demolizione, ricostruzione e attualmente sono state svolte delle prove di tipo distruttive e non distruttive e c'è stato uno studio su un sistema di monitoraggio per questa infrastruttura. Il software che è stato impiegato per modellare questo ponte è il software Midas CIM. In particolare si è utilizzato il modulo Modeler, che sarebbe quello che ti permette all'interno di questo applicativo di svolgere una modellazione tridimensionale, informativa, parametrica. E in poche parole il processo di modellazione è stato il seguente. Innanzitutto si è dovuto creare il tracciato stradale, successivamente ci sono introdotti al suo interno delle informazioni che sono degli oggetti all'interno di questo tracciato e si è creato il mio modello. Gli elementi utilizzati sono stati di 3 tipi, elementi point, libraries, elementi puntuali come pile, spalle, dispositivi di appoggio, lampioni, curve libraries, elementi fortemente parametrici che si basano su una linea generatrice come travi, soletta, guardrail e assembly unit che sono dei template che vanno a concepire, vanno a rappresentare il mio elemento campata del ponte. Quindi lo step di modellazione è stato il seguente. Innanzitutto, non avendo un grande computer performante all'epoca, ho dovuto dividere il modello in 2 parti, perché è un modello molto complicato e molto pesante da gestire, soprattutto se in questo caso non avevo una macchina adeguata. Quindi ho suddiviso il ponte in nord e sud. Successivamente ho creato i miei tracciati, plano altimetrici. Sono state definite questi elementi curve libraries, che in questo caso sono stati gli elementi trave in acciaio e in trave in CAP, ed infine anche gli elementi secondari, per esempio come guardrail e pavimentazione. Sono stati creati gli elementi puntuali, quindi le point libraries, quindi come le pile, spalle, dispositivi di appoggio o elementi di controventatura per la struttura in acciaio. Si è creato questo insieme di queste due librerie per creare questo template del mio ponte, quindi per la struttura in calcestruzzo armato post compresso e per la mia struttura in acciaio. Infine, per rendere un modello adatto per queste piattaforme, per riuscire a introdurre tutte le informazioni necessarie per comprendere la struttura, sono stati creati degli oggetti rappresentativi della mia sensoristica e delle indagini in sito. Gli oggetti sono degli oggetti molto basilari, delle forme semplici, colorate, questo con lo scopo di non ricreare esattamente il sensore, ma di creare un oggetto che per il mio ispettore sia facile da visualizzare. Io devo andarmi a cercare un accelerometro, lo devo trovare immediatamente nel mio modello. E questa è stata l'idea di modellazione, che poi all'interno di questi elementi si vanno ad introdurre tutte le informazioni. Successivamente è stato composto il ponte, quindi nord e sud, e qua si può notare anche il livello di dettaglio per quanto riguarda Sella Gerber, tutta la parte relativa alla bollonatura, elementi non strutturali e strutturali, la difficoltà in realtà nella facilità nell'avere questi applicativi, riuscire a modellare per esempio anche ponti in sghembo in planimetria, e quindi modello terminato. Successivamente esportazione in formato aperto IFC, controllo delle informazioni riportate all'interno di questo formato e poi anche test nel cambio delle impostazioni all'interno del software. Un altro aspetto molto importante è che per un modello bisogna sempre capire quando io esporto il mio file qual è il mio ruolo del mio formato. Se io ho un ruolo che è quello di manutenzione, non ho necessità di avere dei formati con mesciature elevate e quindi con file veramente tanto pesanti, perché poi risultano essere molto scomodi in fase di consultazione. Quindi si è studiato un metodo per riuscire a trovare il giusto equilibrio tra le informazioni riportate e la bontà del modello. Successivamente, quindi, avendo tutti i dati, avendo il modello tutto in pasta, si va a capire che cosa sono queste piattaforme di gestione. Le piattaforme di gestione sono delle piattaforme di tipo online che permettono di costruire inventari di archiviazione dei dati, gestire dei processi di tipo programmato della mia struttura e pianificare invece degli interventi di riabilitazione strutturale, quindi di manutenzione. Ed infine permettono di predire dei futuri scenari di ammaloramento della mia struttura. Quindi avendo capito concettualmente di cosa stavamo parlando, si è scelto di suddividerlo in livelli. I livelli mi indicano il contenuto delle mie informazioni, quindi sono partiti dai dati di primo livello, tutti i dati miei più generali della mia infrastruttura, per esempio codice identificativo INOP, qual è il mio ente che segue questa infrastruttura. Dati di secondo livello invece sono dati relativi al mio GIS, quindi tutto il mio territorio, quindi dati relativi anche a tutti i rischi legati. Dato di terzo livello invece incominciamo ad andare un pochino più sul dettaglio, quindi andiamo a capire quali sono le informazioni dettagliate dei miei singoli elementi strutturali, comprese anche tutti i danneggiamenti, ed infine dati di quarto livello, invece quelli relativi alla sensoristica. Per i miei primi tre tipologie di dati si hanno due possibili soluzioni. Una soluzione è quella di introdurre tutte all'interno del modello BIM, esportare in IFC ed introdurre le piattaforme di gestione. Invece per una seconda opzione invece è quella di avere un modello BIM e passare le informazioni all'interno delle piattaforme di gestione, però risulta poco ottimizzato, almeno per me è meglio la prima opzione. Invece per quanto riguarda i dati della sensoristica, l'introduzione è tutto all'interno direttamente delle piattaforme di gestione, non passando all'interno dei modelli BIM, essendo dei modelli tipicamente di tipo statico. Quindi in conclusione, piattaforma di gestione ottima per comprendere la nostra infrastruttura, conoscerla giorno per giorno. Sistemi di monitoraggio permettono di conoscere lo stato di salute sempre, sono indispensabili soprattutto per le strutture tanto attenzionate. Adesso ci sono dei grandi studi per quanto riguarda l'analisi e pulizia del dato, creazione di modelli predittivi, e attualmente in Midas CIM c'è un grande sviluppo per quanto riguarda la volontà di avere un software fortemente OpenBIM, con quindi anche l'introduzione del 4.3, e anche l'utilizzo di un software InfraBIM facilita anche molto la modellazione di strutture. Infatti ogni software è adatto per l'ambito che si vuole andare a modellare. Quindi se avete poi volete altre successive informazioni, mi trovate qua allo stand CSP FEA e questi sono i miei contatti personali. Grazie.
Grazie Rodrigo. So thank you for all to attend the presentation. We are running a little bit out of time, so if you have any questions, you can reach the speakers during the lunch break or in the other coffee break. So thank you to all of you to attending this session.